Hey everyone, welcome to this Meta System Design mock interview. Very pleased to say that we have a lead engineer with us and he worked at Meta for a number of years. Karthik, thanks for joining us today. Give people a quick intro into your background as an engineer.
Sure. Thanks, Tom. Thanks for the opportunity. So yes, I am a senior manager in a financial institution, and I have close to 15 years of data engineering experience, designed complex systems and implemented it. And in my previous life as metadata engineer, I have done plenty of system design interviews, and I have participated and interviewed it myself. So I'm glad to participate in one of them today.
Yeah, well, very glad to have you on. Let's crack on with the question. Karthik, how would you design Instagram?
Let me quickly share. Good. So it's a pretty interesting system, and it's one of the popular ones. So as far as to kind of like brief what Instagram is, it's going to be having a plenty of features on its own. So it's primarily used for sharing, uploading, and sharing the photos and videos. And yeah, you should be able to look at photos, like, comment, and tag, and whatnot. So just to just for the sake of this design, what are the primary features that we are actually looking at in this vast social networking system?
Sure. I'd like you to design the upload feature, a search feature, follow ability, and newsfeed as well.
Okay, that's good. It's plenty of them. That's good. So good. So upload, search, follow, and newsfeed. Cool. So just for my, so I always get confused with this one. So I'm going to write the follow and followee and the follower here. So the follower is the one who's following someone. And then the followee is the one being followed. Yeah. That's good, just for my clarity. Okay, so like to organize it a bit. Probably the way I would like to take this is we'll spend the next 15 to 20 minutes understanding the requirements, and then like functional, non-functional, and different categories of it, just to understand the system that we are designing a bit more. Then we'll move into a data modeling part of it, and then we'll move to the detail design. Does that sound okay?
Yeah, sounds good.
Cool. Okay, cool. Let me just try here. Okay. So I'd like to probably start with, just going to put this one here. Okay. So let's probably start with the functional requirements. Yeah, which is something I think I can get it from the scope. So we need an upload, download feature, and we need to be able to search. I assume search based on the title. Yeah. Okay. So third is follow. Yeah, a user should be able to follow. That's what I mean. Okay. Then fourth, I should be a newsfeed, which is something that needs to be rendered when the user logs in. Okay. So this is where I will need your input here in terms of the NFRs, the non-functional requirements. So what are we looking at in the system? Like, what are our top non-functional requirements that we are looking at here?
Sure. Well, it needs to have high availability.
Okay.
It's going to have obviously a geographically distributed user base.
Okay.
Newsfeed latency, I like it to be less than 1 second. Okay. And like it to be highly reliable.
Okay, that's good. Pretty performant system. So highly reliable. Okay, good. So okay, so we wanted a very highly available system which has geo distributed users. It's good. So, and a newsfeed less than 1 second, and a reliability plays a very important role. So that means like we have very less tolerance for any data loss. Okay, Cool. Okay, so so now we defined this one. Is there anything else that you would want to design for, or we just like designing for these things? I think we're
Yeah,
not really
that's
taking into
fine.
account the likes, tags, and comments, and all those different features, right? For now.
No, let's leave that out of
Yeah.
scope.
Okay. Cool. Thank you.
When you're asked to design one of these vast systems, the first thing you need to do is clarify the scope of the question. Here, Karthik clarified which Instagram features he needed to implement in his design. Being clear on the requirements is really important as a foundation for the rest of your answer. Functional requirements translate into your APIs, while non-functional requirements will influence the design choices you make. What type of scaling is required, what type of sharing, etc.
I'm going to make another one. I like making this. So I'm going to define some APIs. So I would like to start from APIs. Okay, so let's do in the interest of time, I'm going to just do the prefix here. So this is the prefix that I'm going to be pretty much using for all type of APIs. I like to version it all the time so that it can help with the backward compatibility, and then versioning is always good. So I'm going to define the API. So I'm going to categorize it in terms of reads and writes, what we want to do, and reads, just for clarity, it's like a get, and write is post. Cool. Now, obviously, we want from the reads perspective, we want to be able to download photos, and we want to be able to search, and the search could be based on the title, which is what we said in the functional requirements here. And then we have the follow. So the user should be able to click the button. Through that, he or she can invoke the API, and then should be able to follow another user ID, another user, Scrum user, right? And then we have fourth, which is a newsfeed, which is kind of like a get newsfeed, which is a default behavior when the user logs in. You should be able to render the newsfeed. So in terms of the okay, this doesn't qualify here. It's not really a get here. So what I'm going to do here is I'm going to put this into the rights area because it's more of a post. I think these are all reading something, and this is more of like making some changes or writes into the database. So that's there. So from the non-functional requirement point of view, I'm just going to put some design thoughts. I would like to call it as like initial design thoughts based on what we have here. So we wanted to have high availability. Obviously, we should have replication. It could be storage, the processing services, etc., and then the redundancy or redundant services, which will help us do the high availability, achieve this goal of high availability. And we have the geo distributed distribution of users. Start good. So that means we have users all over the world. So we should have the distributed servers, and then we should be able to serve the content in a very quick way. So CDNs or content delivery networks can help us with that. Faster retrieval from especially these photos and the newsfeed. The third is newsfeed, yes, which has a very tough kind of like performance requirement. It needs to be within 1 second. So yes, CDNs can partly help with that, but we might need to think about some cache or pre-population of news feeds. So I think the reason being news feeds are going to be really read heavy, and especially if there are users who have a lot of followers, or then and then if you want to, if the user is following a lot of people, and if you want to render a news feed from all those people right at the time when the user logs in, if that particular service is going to grab all those users and then get all those top photos, it's going to take a lot of time, and definitely meeting this performance requirement would be a challenge. So that's why these two would be a very crucial factor. The pre-population will help here, so we don't really need to do a hard work. All the hard work would have been done much before.
Okay.
And then highly reliable, yes. We should have replication of data as well, in terms of the mainly the for photos and videos and all those large objects. We use object storage primarily, so which by default gives you that high reliability. So that is something that we can leverage for. So does it sound okay so far? Any questions?
Yep.
Okay.
Yep. No questions. Please continue.
Okay, thank you. And I'm gonna just make a copy of it.
Split the APIs as read, get, and write POST sections. For each functionality, perform high-level translation into one or more APIs. It's always good to note down some initial design thoughts here as well, combining the functional and non-functional requirements so far and checking in with the interviewer.
Now, I'm going to get to the interesting bit here. So, metrics. So, I would like to probably categorize this metrics as kind of TPS, transactions per second. And then bandwidth. And then like to go into the storage as well, just to have the capacity estimation of how much storage we might require, because given that we are dealing with a large objects, so it's definitely going to require a lot of storage, and it would be good to have that kind of that estimation. Right. So I'm going to start with let's start with what is the total number of users. Maybe I'm just going to make some space for myself here. Okay, so may I know what is the total number of users that we have on the platform?
Yeah, sure. Let's say 1 billion.
Okay, 1 billion. That's huge. Cool. And what is our daily active users on the platform?
Yeah. I think we can say 25% of those would be daily active
Okay,
users.
so it's pretty popular system. So 25%. So looking at close to 250 million daily active users. So cool. Let's I would like to make this category so reads on, and then probably writes, right? So just to start with, we have 250 million daily active users, and let's say 100. So we say them as a daily active user. So 100% of them is going to log into our system on a daily basis. On an average, I think it's reasonable to assume on an average they log in, like say 10 times per day. Please let me know if that doesn't seem reasonable.
No, that seems fine.
Thank you. So I'm going to assume all 100% of our daily active users are going to access the system on a daily basis. Yeah, kind of make then access 10 times a day on average. Okay, so that means I'm going to say it's like 250 million, 250 million into 10, which is 10 times a day, right? So it's like 2,500 million requests per day. Okay. So I would like to ideally have understand what's requests per second. So, and I would like to approximate per day number of seconds to 100K just for the ease of calculations. But so if I just use the 2,500 requests divided by 100K, which is roughly so 100,000. So it's going to be 25,000, I think. Sorry, so 100K, it's 25,000. So it's 25,000 requests per second. So it's 25,000. Yeah, 100. Yes, it's 25,000 requests per second. That's the transaction or the TPS that we are looking at for reads. So seems like a pretty read heavy system, right? And then from the bandwidth perspective as well, I'm going to assume probably, let's say, when we retrieve this newsfeed, it's gonna actually have a lot of photos, because I'm going to assume on an average we have a 200 KB photo that's going to be retrieved. It could be large or it could be lesser, but on an average, I'm going to assume like 200 kb. So that means so for every 25,000 requests, which we know, and each request is going to bring me a 200 kb, which I'm going to say is an average size that's brought in, and then we have yeah, so it's 25,000 requests per day, and then it is going to bring 200 KB of size. So, which I believe is roughly around 5 GB per second, because this is happening every second. So 25,000, 25. So it's going to be 50,000 kilobyte, and it's 5,000 megabyte and 5 gigabyte. Yeah. So now just switching on to writes. I'm going to make an assumption here. So not everyone who's daily active is going to upload photos. Most of them are going to be reading or going through the browsing the newsfeed. So they may not be creating the content. So I'm going to assume, like say, 10% of DAU uploads one item on average. Does that sound like a reasonable assumption?
Yeah, I think so.
So yeah, cool. So DAU we have is 250 million. So I'm going to just like say 10% of them. It's going to be say 25 million 25 million items, because we have only one item. It's like per day on average. So 25 million. Once again, I'm going to use my assumption of 100K. Why it's not here? Okay, it's 100K seconds per day. So that's going to be 25 million divided by 100K, which is going to be roughly about so 25 million, 25 million, 2 million bytes, and then so it's like 2,500 million bytes. It's going to be 2,500 megabytes, and then let's say 50 to 50. So it's 50 photos per sec. I'm just going to recheck my calculation here. So it's 25 megabytes. It's million is 25 MB. Yeah, so 25 MB and then 25. It's 100,000. Yes, 250 photos per second. Then I'm going to be looking at the bandwidth as well. So which is 250 into, I'm going to assign the same 200 KB. It's average photo size. So it's going to be 25 is 50 MB per second. That's roughly. Yeah. Yeah, so 250 MB per second. So I'm going to just estimate the storage as well. So how much is for 1 day of photos? So we know from the previous calculation we have 25 million. So 25 million into, we estimated at 200 KB, so which is roughly equal to, so 25 million, 25, 5,000 megabyte, 5,000 gigabyte, and 5 terabytes per day. So it's 5 terabytes per day. So 1 year, roughly about 60 terabytes. So it's kind of like for our capacity estimation, but this is once again, I would add probably an additional 20 to 30 or maybe even 40 terabytes for the metadata as well. So if we are estimating capacity. So yeah, so we have reads, we have writes, and from what we can get from here is it is pretty read heavy system. So we are looking at 25,000 requests per second, and the bandwidth is 5 gigabyte per second. That's the minimum. And from the writes perspective, it's not that heavy, so we're still looking at it around 250 photos per second, and the bandwidth is considerably reasonable as well. And yeah, storage, nowadays now storage is cheap, but still it's like from a, if you look at it, if we extrapolate it for, like, say, for 3 to 5 years, yeah, it's still not huge, it's not going in a petabyte range, but still we're looking at around 100 terabytes per year. So is that metric sound reasonable?
Yep, that sounds reasonable to me. In this sort of system design question, you usually need to estimate the daily active users, transactions per second, the network bandwidth, and the necessary storage capacity. As Karthik did here, you should also estimate reads and writes per second to give you an idea of whether you're designing a read or write-heavy system, and adapt your design accordingly.
So I'm going to jump on to the data model quickly to identify the primary entities that we are looking at based on our functional requirements. So we want it to be able to upload, download, search, follow, and then newsfeed. So I'm going to say probably bring this guy. So first things first, I'm going to probably, yes, we'll have users and have the user ID, and yeah, so could be teacher or sometimes long because we have a pretty big user base, and you'll have typical, so for example, first name, last name, email, add, probably I'll have one more, email, date of birth, and probably address, and most importantly, I would like to have one more as well here. So it is a creation date. Yep. So when this particular entity was created. The next one, yes, of course, we need to have photos. Yeah. So photos. So obviously you have a photo ID to uniquely identify that photo and which user it belongs to. So I like to have this as a foreign key pointing to the user. And then obviously this is going to be a metadata because we're not going to be storing the photos into the relational database. So we will be storing into some kind of object storage. So we need to know where this particular storage photo is located. So that's why this location could be important. And then title. So one of the things that we discussed about here, so we should be able to search those photos based on the title. So this would be very helpful here for our functionality. And we could have some description, and then location. So I would like to have longitude, and I would like to have the created as well. It's creation date, or creation date could be helpful. Metadata. Then we have follow. So I would like to have. So yeah, this could be helpful. Maybe I don't really need this. Gonna say just okay. Okay. So say okay. So I'm gonna call this as user follow. So this could be like I said, this could be a follower ID. So hang on, let me think. So follower ID and follow EID. Yeah, so follower is the one who is actually following someone, and followee is the one who is being followed. So maybe it makes sense to have the followee ID. It depends on. This is something that we could probably discuss as well. In terms of the storage, in terms of the optimization for retrieval, we can design in optimal way. So I'm just going to leave it there. From then, I'd probably one of the things that we discussed is a newsfeed. So I'm going to create an object for this one. So yeah, so here, I'm going to say newsfeed. Simple. So yeah, so newsfeed is gonna have two composite primary key here. So one is going to be user ID, so user who created the newsfeed, and then there's going to be I'm going to be giving a unique ID for each of the feed as well, right? So just to identify each of those feeds, which could be helpful. And so this is going to have feeds. I'm going to say I'm going to say it's going to be an array of feed. I'll explain that in a moment, and why it does this. And then again, once again, I'd like to have the just I don't know if I can delete multiple things, but I don't want to really mess around with draw.io. So gonna just select here and add one more. So here is going to be creation dot, my favorite one. Good. So so this one I'm thinking here. So we need to store a complex structure here. So this it's going to be array of feed. So when we say array of feed, looking for options here. It's good. So can assign a feed object can have, for example, a feed sequence number. Just for so this feed, a feed ID could actually this is the one that we can probably use to bring in the latest feeds at a later point in time, and each of that particular entry can have an array of feeds, because it's kind of like the one that I mentioned before, where we can pre-populate these feeds in order to achieve a requirement of less than 1 second, because we don't really want to render and then do all those complex things right at the moment when the user logs in, and then because then we will not be able to hit this target of 1 second. So in order to do that, what we can do is this news feed, we can use that as for a user. We can generate a bunch of feeds, and then we can order it based on the creation time, and that could be a service that can do that. and these bunch of beats, bunch of feeds, each of them will have the sequence number as well. So to order, which we can use it for ordering as well. And then there is photo ID. That means like which photo it is, and then yeah, pretty much we can have whatever information that we would want to have, what this feed data should have, which will be helpful for rendering the newsfeed faster, right? So this is, I'm just going to and so one more thing probably, which I think is good to have, is this. I would probably use it for metrics collection. So when we want to render a news feed is one of the complex things in the systems like that, the systems social networking platform, because it depends on various factors. It depends on the users. It depends on the, for example, even in the daily active users, and who are the ones who are actually logging in. And suppose if some of them have not logged in for extended period of time, there is no need for to create those no news feeds for them beforehand, because there's not much of an activity in the last few days. And also some of them could be very active, and probably they do not want to wait every time, and then probably every time they scroll, they will scroll more and more. So we would want to probably have a good set of news feeds generated beforehand for them, so that when they log in and then scroll through, they will be able to retrieve those newsfeed in a faster. And so these are few examples of why these metrics or activities, why the newsfeed gendering is dependent on multiple factors. So this user activity table is one of the entity that will be capturing these information. For example, it's last login time. So we can pretty much use this information to see, if this particular person has logged in anywhere, anytime in the last 1 or 2 days. If not, probably we'll keep it as a last. Maybe we will not. Maybe it's not a priority to create the news feed beforehand for this particular person. So that's one thing. Then a follower count, which is another thing. So for this particular user, what is the follower count? Is it kind of like a celebrity user having millions of followers? So in that case, we would want to treat them as kind of a power users. So these power users will have the news feed for these power users will have to follow a certain different approach, because we don't want to keep on rendering refreshing the news feed of 100 million followers every time this particular person uploads or something. So we want to be very selective. So whenever this particular person uploads that, then we want to be selective in terms of, out of those followers, who are the most active followers. And then in terms of last login time could be one of the metrics that we can use that, and we can use several other metrics, which is I just quoted one of them. So does that make sense so far?
You need to identify the main entities of your system that are required and the attributes. So go back to your APIs and think which entities are required to implement each one. Karthik also made good use of supplementary tables, such as his user activity table, which achieved efficiency for the newsfeed.
Now move to the high level design. Okay, so one of the things that we touched upon in our initial non-functional requirements especially is it's a geologically distributed user base. So you want to account for that. So what I'm going to probably do is I would like to have a gateway. So a gateway is to just have a similar one single entry point for these users. So going to probably just say here. Sorry about it. Could be here. Okay, going to bring in just okay. So So okay, so okay, so I would like to have a load balancer. Obviously, I would like it to take care of geologically distributed users as well, so to balance the load to the nearest source. So I'd like to have probably application load balancer here, right? So these are pretty, I think, usual things, the usual suspects, maybe. So yeah, so we have the users who can use multiple devices. So that's one of the things. For an app like Instagram, we have mobile website that can use. So the user can use pretty much any device and then send out a request, and that goes through an API gateway and then the load balancer. Right. So now, if I go back to the functional requirement piece, so we want to be first, we want to be able to, let's say, upload and download photos. So say here, can I make it probably 14 here, just for the space. I'm gonna say upload or download. Oh, yeah. So download, upload. So we get this API. So it's going to I'm going to have a media service. I'm going to call this as a media service because it's going to be predominantly media that we are going to upload or download. So this media service, the load balancer is going to sorry. So the load balancer is going to send this request to a service, the media service, and I'm going to also format it a bit. There's not this one. I want this thing here. Okay, so I'm going to just say yes. So I'm going to be sending the request, and I'm going to be getting that back as well. So we have the user. So you have the user here, and then the user is going to issue trigger a bunch of API. And for a system like Instagram, the user is going to use multiple devices. For example, you can access through mobile, you can access through website, etc. So and so I'm going to use the API gateway here. So API gateway kind of serves as a single entry point for all those APIs that we have, and we can also enforce some security rate limiting because there's a huge number of users, 1 billion users, and we don't know who the bad actors are. Sometimes we would want to protect all those users from those bad actors. So we would want to do the rate limiting, authentications, authorizations, and all the niceties that comes with that. We should be able to do that with the API gateway as a first level of defense for that. Then the request can go to the load balancer. So the load balancer, I'd like to mention one thing which kind of like we talked about in the which we talked about in the non-functional requirement is a geo distributed users. So the load balancer is geo aware, should be able to distribute the request to the nearest servers for doing the work. And you have this media service. I'd like to call this a media service. A media service, the responsibility of the media service is going to be basically serving these requests of uploads and downloads. One of the things that thinking about now is these are pretty large data. So the photos can be huge. Of course, we will have some kind of file size limits that we will check while the user uploads it, but we still don't want the user to keep waiting because that would not be a good user experience. So always in terms of in things like that, it's good to have queues for asynchronous processing. So I would like to have message queues here. So as soon as the user request comes in here, and it can go into the message queue. So this message queue, just yes. So it's a message queue, and then there can be which I would like to call an uploader. So the uploader, as the name says, is going to be responsible for uploading the data. So, and it's going to upload the data into storage. So I'm going to, so I did talk about storage bit here. So I am going to bring in this storage part. And then I'm going to be using few storage here. First things first, I'm going to be using an object storage. So search for object storage. Yep.
And
Yep.
yeah, if I could jump in at this bit, I just wanted to ask you, how would you
Yep.
scale storage for? This is obviously a very read-heavy system.
Yep.
So how would you scale storage for a
Yep.
system like this?
Sure, that's a good question. So yeah, I did talk about the storage moves from the relational point of view here. Yes, so there are a few ways. Definitely, it's a read-heavy system, and it's also geologically distributed. So, and one of the initial design thoughts that we discussed, it's more in terms of we need a replication and redundancy in order to be able to scale the system. And also storage plays a very important role. The storage from the relational, so I'm going to be using few storages here. One for the object storage, that is going to be primarily hosting all the media, photos. So, and then I'm going to be using a relational storage for the metadata, pretty much the entities that we discuss here. And then I'm going to be using a NoSQL as well. So to answer your question, so the object storage by design, we have a pretty it's pretty performant, and it's pretty reliable and scalable. I mean, so we can it can host unlimited number of objects. So from the relational database point of view, we can employ a few techniques like sharding for metadata. So the metadata, obviously, we have the heavyweights are stored in the object storage. So all we are going to be having is the metadata, but still we still are dealing with the 1 billion users. So we definitely need to shard the database. The sharding, we can use few sharding techniques. We can shard based on the users, but and so that all the user requests, when the user logs in, for example, the data that the user database data, if it is sharded based on the user ID, then we can find all the relevant information about that user in a specific server. So we don't really have to look into multiple servers for getting the data. That might take extra bit of time. When it comes to NoSQL, the reason I said I will use a NoSQL here is I want to primarily use it for the newsfeed. So the reason being, we are looking at a pretty performant newsfeed, and we are looking to pre-populate, like I mentioned when I was designing this. We are looking at pre-populating these news feeds beforehand, which we will talk about in a moment in the design. So I would want to use this NoSQL here, so that we can retrieve that data faster in microseconds or latency.
Okay.
So to just summarize, yes, object storage is by design scalable, and it's also reliable. And for a relational database, we can use the shards, so that we can have specific user information available in a specific server. That way, we are not going to be overloading the server, and we are using the NoSQL specifically for certain functionalities like newsfeed in order to make the retrieval faster. So does it answer your question?
Yes, that does answer my question. Yeah, thank you.
Okay, thank you. So yes, okay, back to that. So like, thanks for the question. So that kind of like nicely makes me go into that storage a bit more. Relational DB, or I'm going to say just say database. Okay. So I'm going to just use this. But okay. So database. Yep. And then yeah, I'm also making sure that I'm not really sticking to any specific technology at this point, more at the conceptual level here, because we can pretty much fit in any technology. For example, we can use DynamoDB, or if in the Azure world, we can use Cosmos DB, or for the object storage, or so we can pretty much use any of the technologies. So just more designing it from a high level, from the conceptual point of view. So yes, this one, let me see, SQL. So this one is a yeah, database. So now, so this is the flow for the upload. So it's the media service, and then I'm going to be using the queues, and then upload it into. I'm going to be sending this to back. Yeah. So and this upload service is going to upload the object here, but we also have the metadata, and the metadata will go into the relational database. So now we designed the upload one, and also we in the model we look at it. Okay, when we upload, we need to generate some IDs as well, and it needs to be unique as well. So I would like to have some kind of unique ID generator here, so that can help me with this unique ID generation. Yep, I'm going to be just doing it. Yep. So now, so I said both upload and download. We're using the media, making use of media service. So we need to have some another service for retrieving the photos, or downloading the photos. I'm going to call it as like retriever. So, and I'm going to be this media service. Once it receives a request for retrieving the data, it's going to send it back to this, and this retriever, obviously with the information that it has got, the photo ID, it needs to probably look into the metadata that it's going to search here, and then using that metadata, it's going to look at the object here. Okay, it's going to look at the object here. Yeah, and then it's going to retrieve that back. Okay, so I'm just going to tidy this a bit. Okay, so yep, yeah. Okay, so now this retriever service is going through there, and one more thing that we probably it's a good time to introduce would be we talked about CDN, content delivery network as well. Going to use a cloud CDN here. So this cloud CDN could be another nice thing, because we have a geologically distributed user base. So if the content is already available with in the CDN, then we should be making use of that. And this CDN can behind the scenes talk to the source, which is the S3, and then can if it is not available in the CDN, then we can always go back to the source, and then so it will retrieve the data and then store it here, and then it will serve to media. So the next request, when it comes for the same photo, for example, it can be served better from the cloud CDN, which is more geologically closely located, right? So that's the section. Then I'm going to be, so we covered upload and download. So I'm going to quickly go into the newsfeed and touch base on that. So here, I'm going to call this a newsfeed, for example. Newsfeed, newsfeed. Okay, so the news feed, I'm going to call this as a feed service. Okay, so like I said, one of the things that we need to take care in terms of feed services. It's a very complex service, and it works on multiple algorithms behind the scenes because it needs to bring in the top photos from all the followers. It needs to look at all the followers and then bring in the top photos. So like we definitely need to have some sort of cache, like we discussed during the data modeling as well. So we definitely need to have some kind of cache for this one, and it is going to, yeah. So yep, yeah. So, yep. So I'm gonna just make a bed. Yeah. So we have some sort of cache here. And this feed service, when the user logs in, so the default action that the user expects is it should be able to retrieve the feeds, the latest feeds from the users that the logged in user follow. So this feed service is going to use a feed generator. So first thing first, it's going to check in the cache if this particular if there is a feed already ready for this particular user, and then how latest is it. Suppose sometimes the feed has been generated, but it has been generated 2 days back, but the user is not logged in for 2 days, and then it was not generated after that. So maybe there is some kind of an expiration threshold that we can set so that the user always gets the latest feed. So this feed generator service is something that can be scheduled to run frequently. Maybe not frequently. It might be no, it could be scheduled on a, like say, 15 minutes once or 20 minutes. One depends on how frequently we want the cache to be updated. So this feed generated service can update this cache on a regular basis. And the feed service, suppose if it's not able to get the data from the cache, then it needs to trigger a feed generation, a forced feed generation for this particular user. Obviously, it's going to be an expensive process. Uh, but the point is, we should have some kind of a fallback mechanism. If in case that feed is very outdated, we should be able to at least retrieve the top 10 or 20 feeds for the user. So that's what this is going to do. So it's going to request a feed generator service, and the feed generator service, okay, says, okay, fine, I need to now generate the feeds. And it's going to look at these metadata from the relational database. Okay, for this particular user, who are the followers, and then various other parameters. Like I said, the followers, who are the what are the top posts from each of those followers, and then picks up those photos, and then it's going to retrieve those photos from the object storage. I am going to just do like that. Sorry. So it's going to retrieve that, and then it's going to supply it back to the feed service and then through to the user. Now, sometimes one of the things is like one of the caches may not be enough. Like I said, in a data modeling, we might really need to handle these kind of power users separately. So because these are the users that has huge fan base, 100 million followers. So every time there is an update or from that particular user, we don't really want to notify or render the news feed for 100 million, because 100 million, out of those 100 million followers, probably only 10% of them is going to ever log in probably in the next 1 hour and then see it. So we need to prioritize the rendering part and the algorithm which uses that. So we don't want to really we want to minimize and then minimize the compute used and then focus that compute in the area that would be most required, rather than spending it on the particular case where it may not happen. So, for example, spending it on 80 million users who may not log in the next 2 days to see it. So we can probably render the newsfeed for them at a later point in time. So we need to have some smarts in that. So for that, we need to be able to identify these power users, which could be dynamic, because every time a user, say that there could be users who are having a gradual increase in the follower count, and then suddenly they became popular, and then they have a huge number of followers, and then so our systems can, the power user service can be one of them that can identify the users as power users, or flag that users as the power users based on various criteria. And um, and this feed service can use this information to make some smart decisions. Suppose if it's a power user, and if that power user has, suppose if this user, if the user is following one of the power users, and we might need to, say, probably render the latest post of that power user alone separately, rather than storing all those information directly in the cache beforehand, because it's going to take a huge number of compute. So we can use that information. So this is going to be the feeds that is going to be generated, and even the feeds is going to use this NoSQL, because we did discuss about the feeds information in the data model, that we are going to store it in a NoSQL for ease of rendering. And we can have a profile service, or an admin service, I would like to call it. Yeah, we do have one more, that is a followee service. You can say follower service. Then this can get this API, and then it so basically it is going to just update the relational database metadata. So with relational data for that user who the user is following. So that is the API that this is going to do. So so there is, and even for the power user, and I don't think, I think we might require a few more cache here, but we need to probably analyze the system on a dynamic basis. I think at the minimum we need one for the power users, because every time the user, I think there will be a lot of users who will be following a lot of power users. It's not really advisable to render all those information at in the runtime. So this particular cache can definitely be helpful in storing some of the information beforehand. So that is uh, that is the use of that. Yeah, there is quite a lot happening. So, how do you feel so far?
When you start on your actual design, it's a good idea to implement one API at a time from end to end. In this case, Karthik implemented the upload, download, newsfeed, and finally, follow. Karthik's design was very complete and he showed a breadth of knowledge, responded well to the interviewer's question. Yeah, I think it's a very complete design, a lot going on there. I think we're running out of time, so
Yeah.
if you could bring it to a close. If you want to take a minute to sum it up and maybe refine anything that you want, and then we'll.
Yeah, sure. Yeah, basically, yeah. So so we did implement. Basically, we did implement the functionalities that we discussed here. So starting with the functional requirements: upload, download, search, and then follow our newsfeed. And search is something that we can use. We can make use of the adminer service, which I have not really mentioned here, but we can pretty much search based on the title. That's the reason we had this. We have this in the data model. In the interest of time, that I have not mentioned here, but it's another service that's going to be used, pretty much. We can use for searching the photo. So we did design the high availability. Like one of the things that we discussed is, we need to shard, and then the NoSQL is by design distributed, and object storage is highly reliable as well. So we did take into account that. And the geologically distributed users is something that we handled based on the using the load balancers and the CDNs for CDNs and the caching mechanism for serving the newsfeed in less than 1 second, or maybe in a more performant way. So this is a read heavy system. So that means that's why we have the bottom portion covers the reads most of the read specific things. Of course, there are a few things that we would really need to go deeper into in terms of what type of algorithms that we're going to be using for rendering these news feeds. And one of the things that we discussed is we can use a user activity, but that's not all. So we can use a lot of different metrics to effectively render the news feeds. And some of the things that we need to take care is like how do we shard these tables. So one methodology that we found is like we can shard based on the user IDs, so that for a particular user the data can be easily found. So yeah, and then this is asynchronous mechanism, so that the upload, so the user doesn't have to sit and wait for the upload to happen. So that's pretty much it. Of course, there are a few things that I mentioned which might require a bit more detailed consideration of use case, but overall this covers the scope and functionality.
Great. It's not possible to design Instagram in 45 minutes, so the important thing at the end is to talk about trade-offs and mention things that would require further discussion. Karthik did this by mentioning sharding techniques and the different algorithms that we'd need for the newsfeed. You need to show the interviewer that, given more time, you'd be able to refine your system. Excellent. Well, that brings us to the end of the interview. Thanks, Karthik. Hello, really hope you found that useful. If you did, you can like and subscribe, and why not come visit us at IGotAnOffer.com. There you can find more videos, useful frameworks and question guides, all completely free. And you can also book expert feedback one-to-one with our coaches from Google, Meta, Amazon, etc. Thank you, and good luck with your interview.